Welcome to today's lesson. So today we are proceeding with the magnitude of a vector, or how to determine or find the magnitude of a vector. Now let's take or consider this vector from the origin to this given point. And then this can be named by, let's say, the name of this vector is, let's say this is vector A, and then is given by, this is 6, 6. Okay, so this vector can be called 6, 6. So this is 6, 6. Okay. Now our aim is to find or how can we get the length of this vector. By doing that, we can draw another line, given line, from the given vector to the x-axis, and we can say that what we have found, what a triangle here, a right angle triangle here. Okay, so we can see that what the 90 degrees is formed here. All right. Now from the Pythagoras theorem, we can identify that what we can be able to get the length of what the hypotenuse. So this becomes our vector A becomes what the hypotenuse. Okay, so if that becomes the hypotenuse, that means that let's name here to be what our, so this is what our y, and then this is what our x, right? So our A squared from the our Pythagoras theorem, we can see that what this is going to be equal to what y squared plus our A squared, right? Now we are looking for the length of what A, so we are going to say that A is equal to the square root of, oh, this is not A, but this is what x. Let's identify that. So this is actually x, not A. All right. Okay. So we are going to see that A, the length of A becomes y squared plus x squared. Since addition is commutative, we can bring what x first or y first. The answer still remains the same. But here we know that this is our x, and then this becomes what our y. So the length of A over here becomes what the square root of what 6 squared plus 6 squared. Then A becomes the square root of 72. Right? If you put that into a calculator, you should be able to get root of 72. That is 6 root 2. This is the same as 6 root 2. But let's simplify it further. 8.485. So we are getting what? 8.485. Okay. 8.485 approximately it can be 8.45. Alright? So let's say that, or even 8.5. Let's say that, let's visualize that with our rule here to say the length of our given vector. This should tell us if this our formula is telling us the truth. So when we put that here, verily we can see that what it is giving us. Let's zoom that out. Let's zoom that out. Let's zoom that out. Good. So we can see that what this is becoming, the length of this is what 8.45, almost approximating to what 8.5, almost 8.5. So we can identify that the length of that vector is 8.5. So our length is now 8.5. Let's also verify or look at a different one. Let's zoom that out again. Okay, let's also consider a different vector here. We are considering a separate or a different vector here. And okay, let's use red. Okay, this is also from the origin to this given point. Okay, now let's name this vector. This is going to be, let's say this is our vector v. Okay, now let's take that out. So this is our vector v. We just name it this our vector v. Now our aim is to also determine the length of this vector v. What did we do here? We drew a line to form a line to meet what the x-axis. Drawing that line, we can say that we are going to have This is from this given point. So this is landing next to what? This is landing next to -5. And then the same with draw it to the y-axis here, we are going to get what? -4. So it means that we can name here, this is what? -5, -4. So with what we did here, we identified that what? The length of our vector, so this is v squared, should be the same as, v squared, alright, should be the same as what? If this is what? Our y, and then this is what? Our x, alright. So we are going to say this is going to be x squared plus y squared. Then our v is equal to the square root of x squared plus y squared, right? Then our aim is that we want to find the length of our v, which is the vector v, alright? How do we get that? We know that the x-axis here is what? -5, so that is -5 squared plus -4 squared plus -4 squared. Okay, so this is going to give us what? The square root of this is 25 plus 16. The square root of 25 plus 16. 25 plus 16. Root of 41. Our vector v, the length of our vector v, we are looking at is going to be, which is the same as the magnitude. Okay, is going to be what? The root of 41. We simplify that further, becomes 6.403. So becomes 6.403. Okay, if it's in centimeters, we bring our unit in centimeters. So let's still bring our ruler here to determine if our length that we have identified is true. We just want to say if our length is true in this case. Good. So we are getting what? 6.4. 6.4. 6.4. 6.4. Good. So let's zoom that still out. So yeah. So that we can see that this is going to be 1, 2, 3, 4. 6.4 over here. 6.4. Let's take this out. 6.4. So we can identify that what our given answer is correct. So that is how we determine the length of a vector, or finding the magnitude of a vector. Okay.